Hello, everyone. It's good to have you today. And this is Limon from SuperMap Research Institute. And I'm very honored to share the new features and enhancements in SuperMap GIS 10i 2020. The main highlights in SuperMap GIS 10i 2020 can be summarized as system evolution and technology upgrades. This year, we have the technology evolution from the bit CC to bit DC. The first letter C in red we see in the picture stands for the cloud native. Let's take a look at the SuperMap GIS 10i 2020 technology system. We have the big data, GIS, AI GIS, 3D GIS, cross-platform GIS, and an evolutionary change, which is distributed GIS for optimizing the performance and the experience of processing large amount of spatial data. 6 key technological upgrades, including technology innovations about high reliable geo-blockchain technology and AR, GIS, 3D GIS, and etc. The first one is highly reliable geo-blockchain technology. And we upgrade blockchain technology to geo-blockchain technology this year, which provides high reliable data storage. And Dr. Song just gave us a very detailed introduction on this point. The second part is ARGIS technology based on video-spatialized applications. Let's try to imagine if you are in a shopping mall, consists of such multiple number of floors, especially during your first visit. For me, the problems may be where the restaurant I want to go, and even where am I? That do bother me sometimes. But now, things can be changed by using AR visual positioning. If we confronted with such conditions, just take out our smartphone. The GIS with AR will provide the indoor positioning capability with detailed and accurate location information inside buildings. We could find where we are. Given the position information, now AR indoor navigation could help us to navigate to any point of interest in the real time. And the shopping experience can also be upgraded a lot by using AR map. In this video, AR map helps to identify the store, and then you may get the latest price information and related comments from the internet simultaneously. As we all know, data collection is the basis of mapping. So this year, we're delivering a new method, which is to scan things to collect the featured point cloud in order to draw the map. By using this method, some places hard to access now can be mapped. During the process of collecting, we can see a set of points is showing on right, and the map is auto-generated. AR can use to measurements such as measure the height of the tree, and we can measure the area on the ground. We can have more practical applications when AR is combined with AI. This is a typical application where we can make geofencing on the video. We use AI to recognize plate of offending vehicles. Integrating AR with AI, vehicles that violate the traffic regulations can be now automatically identified and tracked. The third part I would like to share is we're talking about the way in which 3D GIS permeates across different industries by supporting new data type, analytical techniques, and virtualization improvements. And it is really thrilling that we are seeing new areas in which 3D GIS is now approaching. Firstly, new data type is supported now. The CDGML is an open and international standard for representation and exchange of 3D city models. Now, the CDGML is available to be imported and exported in SuperMap GIS 10i 2020. And most importantly, its relevant geometry, topology, and semantic information can also be well kept. Spatial query is a common tool in GIS. It's worth to be mentioned that based on the GPU, we can get spatial query results on the fly, so that thousands of beam components can be queried in a more efficient and interactive manner. And for me, it's hard to imagine using CPU to do the same job, right? GPU is also applied for the underground 3D GIS applications. This year, we're also having a lot of good improvements in analyzing and virtualizing the 3D geological models. We can do the real-time profile analysis, cross-sectioning, aggregation, and so on. Let's take a look at a video. Using real-time profile analysis to virtualize the distribution and the composition of the geological layers. You can do the sectioning we see in the video and the aggregation to observe the interior geological structures and find out more characteristics. Expanding the vertical scale is known as the vertical exaggeration. Explosion is commonly used with the vertical exaggeration in order to view the interior structures, such as the faults and the folds inside the geological layers. Click on certain points to simulate the borehole drilling, and it also provides information about the geological composition under the buildings. And all the relevant information can help to identify geological hazards in advance and for better decision making. Recently, we've talked with some users who have expectations for more appealing visual effects. So we are starting to integrate with popular game engines through i3M. It's for spatial 3D model. It's an open data format for streaming large heterogeneous 3D data across platforms. The value of game engines is extended through accessing spatial data with real geographic coordinates, and the GIS benefits from the realistic and immersive 3D geographic environment provided by the game engines. So we provide the product called SuperMap Scene SDKs 10i 2020 for game engines to deliver cutting-edge interactive experience. As we all know, the Real Engine is an open and advanced real-time 3D creation tool. We come up with SuperMap Scene SDK for these engines. Let's check out the little demos. Now, the Unreal Engine have access to massive beam and man-made models, oblique imagery, and point-collated data through i3M, as we see on the green. This is a demo of simulation on fire emergency. S3M here is to use to represent the oil plant as a GIS-based map. And the particle system you see is created from Unreal Engine for the fire and smoke. It is another good case, illustrates professional GIS software with game engines. And we also developed a plugin for Unity, which is another famous real-time 3D platform. Again, all commonly used GIS data supported in this engine. And what is more, it is an effect of real-time box clip in Unity, and it is quite a useful feature, and which is commonly used for architecture industries. Besides, a series of analysis functions are provided in SuperMap Scene SDKs for game engines too. And we hope this contour map analysis and another spatial analysis can be used for our high-end users. And we do hope the integration of GIS and the game engines may establish a new ecology for the users from both sides. In addition to game engines, there are more compelling 3D effects in SuperMap GIS products. We have the ocean, the sky and clock, and more animated models effects in our own products. In this video, we could see the volumetric cloud floating and fast realistic 3D ocean effect with dynamic waves and real-time reflection. And with this new experience, we are continuing to see more areas where 3D GIS has the potential to contribute. The fourth part is the smarter and more powerful AI GIS. The artificial intelligence technology system was released last year, and in this year, we have more enhancements on model and the GeoAIs. These are the models we released last year, and in SuperMap GIS 10.9 2020, we provide more built-in models such as Mask RCN, FPN, Deep Level V3 Plus, and all that is highlighted in bold. Since different AI model types are designed for various scenarios, users could choose the appropriate models based on their requirements and the characteristics of the data. Okay, let's see what's new in geospatial machine learning operators. This year, we added new 9 operators in geospatial machine learning operators, such as classifications and regressions. It's more than the map matching, logistic regression, and the geosimulations. The cellular automata are discrete, abstract computational systems that can be used to simulate various real-world processes. And this year, we introduced the cellular automata into GIS to do the geosimulations work. And by way of an example, based on the AI and the cellular automata, we use the land use patterns of year 2001 and 2008 to simulate the land use changes between these two periods. The outcome of simulation accuracy is 83%. Besides, with more training and samples, the results can be more accurate, and this could be useful in land use planning. As for geospatial deep learning operators, object extraction in image analysis and the spatial temporal analysis is newly added. And we could train unseen deep learning object detector based on the image data and the samples, and to outline segmentation masks of objects in the images. Okay, let's check out this example. Here's a good example to use object extraction to identify photovoltaic panels. As we see in this picture, due to the low image resolutions, it was hard to identify each panel by using semantic segmentation method. But now, use new algorithm and model, the instance segmentation, the outline of all the photovoltaic panels are well extracted, and the results could be used in further applications. Based on the workflows released last year, we also provide a series of post-processing tools, including the nibble, shrink, thin, and other useful tools to help finish the job better. This is a post-processing example about road extraction in the map. And we see after the binary classifications, we could use the nibble and the majority filter and another tools to improve the result. And the whole process could run smoothly using the geoprocessing tools in SuperMap GIS to make your work less artificial and more intelligent. The next part is the cloud and terminal integrate distributed geoprocessing tools. And this is the transition of the spatial data processing ways. In earlier years, we have to do the repetitive desktop operations, such like the mouse clicks, to finish every step of the processing job. And that means a lot of manual work to do and low efficient. Later, geoprocessing offering a more easy to use method, which is put every different steps into workflows in order to perform multi operations in an automated way. And what is more, in the age of big data, the standalone mode is sufficient to serve huge amount of data with efficiency. Now, we introduce the distributed geoprocessing tools this year to make the tedious works more efficient. And because of the same geoprocessing modeling structure, so the SuperMap server web GP modeling and SuperMap desktop X GP modeling can have the same predefined tools. As a result, the GP models could be shared and reused across SuperMap GIS products. For instance, we could export geoprocessing models from the desktop X and then import it to a server. Then the GP task would run on the web immediately. The sixth part is the fully upgraded one-click migration tools. Since 1990s, many software developers are moving from Windows to Linux operating system for more secure and reliable reasons. And it will become more common in this cloud age. And following these technology trends, in the year of 2000, SuperMap started to the cross-platform developing and released the SuperMap GIS 5, our first cross-platform product. And as we all know, Microsoft Windows and Linux operating system were polar opposites for decades. But now, even Microsoft begins to embrace Linux by releasing such a tool. It's called Windows Subsystem for Linux, which support various Linux operating systems running on Windows. And we test the microservices running on the WSL, and it is much faster than running on the Windows. So maybe it's time to think about using the cross-platform products. In the latest SuperMap GIS product system, we could see the majority of the product is capable of working on multiple operating systems, like many kinds of Linux operating system or the mobile devices. SuperMap GIS now is ready for the platform migration works. In terms of GIS application migration, there are three aspects need to address. First is the data. We must deal with the vector, the grid data to be migrated. And the map, we have the symbol, library, nodes, thematic map, and other properties to be considered. The third one is the service. We have to think about the service and the cache use. And each of them has a lot of work to do. For the data migrations, a series of workflows for migration work combining with geoprocessing tools are provided in the latest version, which obviously reduce the manual work and time cost. In this case, the shape and the AIC and the ECW and the point cloud and the oblique imagery data can be migrated into SuperMap in a very efficient way. As for the map, we also have many built-in tools to do the map migration job. All the styles, symbol libraries, and other related properties of the map will be imported into SuperMap GIS, and all the properties can be remained unchanged. The third one is the service migrations. And when you build up your own service, and completely the same as the previous we have talked about. After the migration, the works you have finished will be perfectly preserved, and you won't be stuck by the changing environment. And as server and edge are accessible by no matter a REST service or tile package service. The works you have done by the previous platform will be inherited by the server, and the user can continue to develop and publish the new services by SuperMap's REST services. And here's my report today. And if you want to know more about SuperMap GIS 10i 2020, please scan this QR code for the details. Thank you.